We're going to discuss basic collection techniques at the scene. And it's important for you to understand that there really is no standard operating procedure for entomological collection. What we do need is a basic set of information provided to us so we can give you the information that you are seeking. So we don't care how you get the information, just as long as you can get it to us. But we do have some standard guidelines we'd like you to go by. We think that it's pretty easy, doesn't take very long, and the equipment is not that expensive. So these are suggestions, and you can incorporate this into your crime scene protocol however you wish. One of the first things you're going to have to consider is what type of equipment you need to do these collections. Some of it is unique to entomology, others it isn't. But you probably want to configure an entomological collection kit long before you need it. Most of the things can be gathered around town in your local area, and if push comes to shove, I guess you could put some of it together very quickly while you were at a scene. Stop at a convenience store and stop at Walmart, and you could probably get most of the things that you need. But there are commercially available collection kits, and I suggest that you look online, find some that suit your needs as a department as far as number of cases you're likely to process a year, and of course your budget. These standard kits are nice simply because some departments require a standard kit. It has to be reproducible. So it's reproducible equipment. So we can give it to the defense during discovery. The defense experts can test your equipment as well to determine its reliability. So standard kits are suggested, not required. There are several standard kits on the market. This is one standard kit. This is actually a kit that's on the market that's the lowest price, that has all of the things that you need to make an entomological collection. If you'll notice, some things you may not already have in your crime scene unit, such as an insect collection device or a fly net. You may not have one of those. There are some soft touch or featherweight forceps that are included in the kit. It prevents you from jabbing the larval specimens, and it prevents you from mashing them, so we don't want to kill them. So these prevent you from doing too much damage to the evidence. Other items you probably already have, such as ethyl alcohol, some specimen containers, a thermometer, a small garden spade, and some plastic containers. So as you can see, with the exception of these little featherweight forceps and a fly net, you probably already have most of this stuff on board your crime scene unit, or at least at your local crime laboratory. One of the first things that you will need to do, and it's probably different from any other type of evidence collection that you are likely to do, is make an aerial adult collection. So you use your fly net and you sweep back and forth in a figure 8 fashion, and you try to collect a representative sample of the adult insects that are flying above the body. And that is the general idea. We don't specify numbers, we just specify a representative collection. So if you happen to do the figure 8 technique a few times and you come up with green flies, and you see a few blue ones and a couple black ones, then keep doing it again until you have at least a black one and a blue one in the collection. So it's a figure 8 motion over the body. Now, of course, you are swinging a muslin and nylon fabric net over the body. So there's going to be some opportunity for trace evidence transfer. And you want to make sure that your trace evidence is collected prior to doing the aerial adult collections. So that is one consideration you have to make. There may not be large numbers of adult insects present, so if it's cloudy, if it's relatively cold, early in the morning or late in the afternoon, you're not going to see lots of adults in many cases, and doing the figure 8 technique may not be very productive. So you can do what we're doing here. If you stay out of the light that the fly is receiving, keep your shadows off of the body, flies really aren't going to pay that much of attention to you. Shadows falling across the body, sudden changes from light to dark tend to elicit a startle response in flies. So if you pay attention to where your shadow is, keep your shadow off the fly, and if you move relatively slowly, you can hold the net as they're doing here, move slowly over the fly, get to just about an inch or so above the fly, and then shake the net a little bit. That scares the fly. The fly's startle response is to jump upwards and slightly back, so they jump into the net. And to escape, flies always will go up and towards light. That's why you always see flies in windows and usually up towards the top of the window. So up and out is, up and towards light is always out to the fly, so they go up into the tail of the net and they tend to ignore that large open hoop. So it's an easy way to collect adult specimens. But, however you want to do it, the object is to put flies into the net. You can use the figure 8 technique. You can hold the tail of the net and approach from behind and slightly above the fly. Keep the insects down into the very tail of the net. Secure the tail of the net with your hand. And at that point in time, when they're secure into the tail of the net, you can fold the tail of the net over and place it into a kill jar. A kill jar is included in most of the commercial entomology kits that are present. And a kill jar is a simple thing to make if you don't want to buy one commercially. It is a glass jar with a tight-fitting lid, and it has some absorptive substrate in it. This is a commercially available kill jar. They're under $4, so they're cheap. And this has plaster of Paris in it. The plaster of Paris will soak up a killing agent. And the killing agents that we've used in the past, we've used chloroform. We've had some graduate students put themselves to sleep with chloroform, so we've stopped doing that. Then we've used carbon tetrachloride. Now that's a carcinogen, so we don't use that anymore. So kind of what we're reduced down to as far as a chemical killing agent to use in these jars is ethyl acetate. Now, ethyl acetate is, of course, the active ingredient in fingernail polish remover. So it's safe to use. It's safe if it happens to come in contact with your skin. So you pour a little cap full of ethyl acetate onto the plaster of Paris. It soaks it up. And then as it volatilizes, gives off fumes. That will kill the adult insects. If you don't have plaster of Paris, you can use paper towel in a jar. It does the same thing. It's a good idea to keep a funnel. Once these adult insects are killed in the killing jar, and there is no need to keep any adult insects alive, you can simply put your hand through the back of the net, evert the net, and dump these now dead adult insects into the funnel, and they will go into a vial of ethyl alcohol. So all adult insects are preserved in a solution of 80% ethyl alcohol. No need to keep any alive. And you can see how easy it is to, using a funnel, to place the adults into the vial. If you don't have a funnel, you can use a thumb and index finger or a pair of forceps and just transfer the insects one by one into the vial. But certainly pouring them through a funnel is much quicker. Once you become proficient at entomological collections, you may realize that a kill jar is one thing that you really don't need. It's another item to have to bring into the crime scene. It's something else to keep in your crime scene unit. It's a glass jar, and if it gets jostled around enough, it may eventually become broken. So you can eliminate the kill jar, and if you want, you actually can eliminate the kill jar and funnel by doing what they're doing in this photograph. I've mentioned previously that once flies are in the net, if you hold it up and towards the sun or towards a light area of the sky, they will go up and towards the light. So knowing that flies will always go up towards the tail of the net, you can hold the tail of the net with one hand and reach under the open hoop with an open vial of alcohol and simply tap the adult insect straight into the alcohol solution. It's very quick, and it eliminates some extra equipment, also eliminates the need to have ethyl acetate. So it's a good thing to do. Just don't be too comfortable about it. Don't do anything that you wouldn't want to see on the front page of the newspaper the next day. So watch where you place your feet. After your adult collections, you want to then take your insect collection device, your net, and you want to do a vegetation sweep. So in a radius of 360 degrees, about 5 feet away from the body, you want to walk all the way around the body, do the figure 8 collection technique in front of you as you walk around in a circle, beat vegetation, and anything that you get from that vegetation sweep, place into a vial of alcohol. You're going to get grasshoppers and beetles and plant hoppers and some fragments of plants and leaves. The plant fragments are okay. You can leave them in there. That just kind of will help us verify the type of environment you may be in. And the vegetation sweep is mainly to collect any adult insects that may have been scared off by your movement. Some of our flies that are very important in a forensic context don't really like things that move much. A little bit of movement and they will go away. They'll go somewhere to roost and until the movement dissipates, and then they come back. So your activities around the crime scene will cause them to move away from the body and go elsewhere, and we hope that doing the vegetation sweep we can recover those adults. And that's why you do a vegetation sweep. These were adults that were on the body with some activity at the crime scene. These adults have left the body and have roosted on vegetation. So that's what we want to recover in the purpose of the vegetation sweep. You can do these collections by yourself. They work best in pairs, and the reason that it works best in pairs is just much more efficient. One person can glove up and focus on actual removing the insects from the body, and the other individual can make notes and create labels. We have a death scene form that we require you to fill out. It's kind of a habitat documentation. And for every collection made, we require you to make 2 labels. A plain paper label that goes inside of the vial, and then an adhesive label that goes on the outside of the vial. And all of these labels are made in pencil. Do not use pen. Alcohol, or larval solutions, which are kerosene, alcohol, and acetic acid, will dissolve the ink off of the paper. So we require everybody to do all of your labeling in pencil. I know it's different from what you normally do. You've been taught to make things indelible and permanent, but for your entomological collections, it all has to be pencil. This is the death scene form. It is available online. It's available in your workbooks. And this is your habitat documentation. If you start at the top of the form, if you answer all of the questions, and by the time you reach the bottom of the form, you will have provided us with most of the habitat information that we would collect if we were at the scene ourselves. So at least as far as the collection aspect goes, you do not have to have an entomologist at the scene. You can easily do what we would do if we were to be present. After you have started to work on your death scene form, you'll notice on the bottom of the form is several blanks for temperature to be added. You have to collect some scene temperature. The insect growth is completely different. The insect growth is completely dependent on temperature. When it's hot, the insects grow quicker. When it's cold, they grow slower. So the only way we can be able to age these insects and give you the information you need is if you tell us the temperatures you experienced and the larvae experienced at the crime scene. So we'll go through the temperatures that you must take. You cannot skip the temperature collection aspect of this. So the first temperature that we want you to take is an ambient air temperature. We just want to know how hot or how cold is it out at your crime scene. And the best way to do that is to do what they're doing here in this picture. One person records the temperatures, one person takes the temperature readings. So the ambient air temperature is best taken at about 3.5 feet high, approximately chest high, and in the shade. So the thing you always have to remember is your instrument always has to be shaded. Do not let it come into contact with the sun. And you can do this directly above the body or close by the body. As long as it's done in the immediate proximity of the body, we're okay. The next temperature to take is a microclimate temperature, and we like you to hold the thermometer about 1.5 feet or 2 feet above the body and record the temperature directly above the body. In most cases, it's going to be the same as the ambient temperature. However, if you happen to be maybe on hot beach sand, the body's in a snowbank, down into a ditch, or maybe in a crevice between some rocks or boulders, you may notice that temperature is quite different. And just a couple degree change in temperature will alter the insect growth. So we need to be very accurate with our temperatures. So we've got ambient, we have a microclimate reading just barely above the body, and then we want you to drop down even lower and take a body surface temperature. And it doesn't matter if the body is wrapped or clothed or nude. We want you to take a temperature of the highest part of the body. And that helps us take into account thermal loading from the sun, maybe. A lot of solar radiation is going to cause that body to heat up, so the body may be hotter than ambient. If the body happens to be laying in what we've already said, snow or on very cold ground, that radiant cooling is going to make the body much colder than the air temperature. So we want an upper body surface temperature to try to account for any thermal loading from the environment directly into the body. We then want you to take a body to ground or body to surface interface reading. So we want a temperature between the body and whatever it is laying on. So you would simply insert the probe up under the body till you feel a little bit of resistance from the body and stop. We don't want to cause any trauma to the body. We don't want to poke a hole in it. But we do need that interface temperature because that is a zone that many insects will tend to live. And if you happen to collect from that area, we need to know the temperature of that area. We then want you to move out away from the body slightly, out past any soil that may be soaked or saturated with any exudates. So move out to clean soil. If it's a fresh body, there's no decomp in the soil, you can do it very close to the body. But if you have a large decomp area, move away from the body. Try to stay within 10 feet of the body, however, and then take a soil surface reading. And we need a soil, so look for bare soil. Don't take a temperature of the vegetation or don't take a temperature of the leaves on top of the soil. Find some bare soil and take a temperature reading. In that same area where you're taking the surface reading of the soil, we then want you to insert the probe into the ground about 1.5 inches or 2 inches and take a soil depth reading. And the reason that we need you to take temperatures of the soil is because when these insects leave the body, when they wander away from the body and go out into the environment, they will tend to burrow into the soil. And they may spend up to 60% of their life cycle out in that soil. If you do not document the temperature of the soil, then we're going to be greatly off the mark in the postmortem interval estimation or period of insect activity that we're going to be able to report back to you. So a soil surface and a soil depth of about 1.5 inches or 2 inches. If you're out west, in the desert southwest of the United States, for instance, it may be a good idea to take humidity readings. Extremely low humidities cause high larval mortality. It also adversely affects the adults. But for most of the United States, this can be skipped. But any type of a humidity indicator would work. You then have to take a temperature of the larval mass. And if you have multiple maggot masses on the body, you take multiple temperatures. So as we've previously discussed, you have a group of adult flies, results in a group of eggs, which results in a group of larvae, and they move through the body from head to toe. So you should have one large feeding maggot mass. Multiple masses can indicate trauma, injury, and multiple masses would need multiple temperatures. So you would simply take the temperature probe, gently insert it into the center of the larval mass, and record the temperature. So it's easy to see these large feeding masses of maggots. This is a test hog very similar to what we have out for you guys this week at this workshop. This maggot mass in this hog is 72 hours old. The ambient air temperature this day is 80 degrees Fahrenheit, and the maggot mass temperature that's being recorded is 102. So the temperatures that the larvae are experiencing inside of the body is greatly different from the temperature that you are experiencing on the outside. And their growth is based completely on temperature. So we really need to know those temperatures. So accurate maggot mass readings are probably the most important thing that you can give us to assure an accurate estimation of period of insect activity. As we said, if there are 2 maggot masses, make 2 collections, do temperature readings. Particularly if you have an active maggot mass in the anal and genital area and a maggot mass in the head. Those are 2 critical areas, may be great importance to your investigation, and keep the larvae that you recover from those areas separate. Never mix samples. The larvae that are collected from the body need to be put in a different preservative solution than the adults. We can put the adult insects into 80% ethyl alcohol. The larvae should go into a larval preservative solution that we call KAA. It's kerosene, alcohol, and acetic acid. You can mix it up yourself. You can buy it readily mixed from many entomological or forestry supply houses. The reason is 80% ethyl alcohol is just not a good preservative for the larva because it doesn't penetrate the membranes of the maggot quick enough to kill the bacterial fauna that they have in their gut. So they will decompose from the inside out, and they'll decompose in a matter of days. And a common problem with law enforcement is they'll make the insect collections, they'll put it in their evidence room for a week or so until they have all their photographs and reports ready, and when they ship it out to an entomologist, by the time the entomologist gets it, those larvae have decomposed. So all the time that they spent trying to make the collections is for naught because we don't have a good specimen to work with. So a larva should be placed in KAA. If you don't have the larval solution, then the other thing that you can do is blanch the larva in extremely hot water or gently boiling water. For every collection you make, as we've already said, we should have 2 labels, one on plain copy paper written in pencil on the inside of the vial, and another one written in pencil on adhesive paper on the outside of the vial. So we have one person making the labels, one person doing the collection, and we have one vial from every area that you've collected on the body. And that's really how it should look when you're done. The information that needs to be on that label is your standard evidence collection information. Your agency, your case number, time and date of collection, the name of the collector, and the thing that may be unique to the entomological side of the house is collection location. When we say location, we don't mean city and state. Exactly where from the body did you collect that specimen? Don't just say from the eyes. Say left eye or right eye, left ear, right ear. We need to know as closely as possible where that maggot was collected from the body. It's a good idea to photograph before you collect. Maybe have someone photograph while you're collecting so we know exactly where you're pulling those insects from, and then photograph when you're done. Another reason those photographs help is in case the medical examiner or coroner may have some questions as to whether you induce some type of trauma during the collection process. Good before and after pictures can help answer those questions. So we've got your preserved specimens, which are by far the most important. The other thing that we're going to ask you to do is to go back to those same areas where you've previously measured temperatures, where you've previously made a preserved collection, and do a live collection. The reason that we make you do live collections is because some of these insect species are not distinct in the larval stage. We have to have the adult stage to be able to conclusively ID the species, and we need a definitive species ID before we can get that developmental information that gives you the timeline that you want. So we make you create a container that can hold the maggots while they're being shipped to an entomologist. And the container is basically a plastic container, any plastic container with a tight-fitting lid. In that container you'll put a little bit of vermiculite, which can be obtained from any home improvement or garden center. And what he has here is some tin foil, aluminum foil. And this aluminum foil sheet is folded into a pouch. Here is the plastic container. The deeper the better on these plastic containers. Real wide and real shallow containers don't work so well. So nice deep containers, yogurt cups, bait cups from tackle stores are another good thing to use. And you take the aluminum foil. You can use some beef liver or soil from underneath the body. Beef liver is what we recommend, and place some larvae on it. So here's the beef liver. It's a palm-sized piece of beef liver. This will keep 50 or 60 larvae alive for 24 hours or so. Once the larvae are placed on the beef liver, which is an alternate food source for them, this foil is crimped over. It's not smashed flat. It's just gently crimped over, and it is placed into the container that has the vermiculite in it. So there it is, folded over. It's placed on top of the vermiculite. One plain paper label in pencil goes inside of the container, and an adhesive label, also done in pencil, goes on the outside. So from every area of insect infestation on the body, you have a temperature, you have a live and preserved collection, and the live collection has 2 labels, the preserved collection has 2 labels, and you've done an aerial collection from above the body, and you've done a vegetation sweep. The other thing that you need to worry about are what about the insects that may have already left the body. They leave the body, they go into the soil. It's a good idea for decomp cases after the body has been removed from the scene or the skeleton has been collected to take some soil samples from the area of decomp, which is what she's doing here. And you can use your garden trowel or spade that's in your entomological collection kit. You can dig up some soil, you can put it in a Ziploc bag, a zipper top bag, gallon-sized Ziploc bags are what we recommend, and you can just send that to the entomologist, and the entomologist will sort through the soil samples and recover the insects. She's made some soil sifters, little hand sifters, and she's actually sifting through the soil herself because she wants to make sure that she recovers some of these entomological specimens. So instead of paying to ship a bunch of heavy soil, she's making the soil collections and she's only going to send in the entomological evidence. Whatever you decide to do is fine with us, just as long as some soil samples are taken. So the soil samples from underneath the body have been collected, and then we have to make the assumption that there are other species which may have left the body and distributed themselves out into the environment. Some stay very close, some just get into the soil underneath the body, others may go quite far. General rule of thumb is they'll stay within about 20 to 30 feet of the body. However, in some cases, even in natural environments, they have gone 25 to 30 yards. They will orient themselves to light, so you want to look on an east-west transit for these dispersing maggots that are leaving the body and trying to seek shelter out into the environment. So just as your point of reference, the remains were here. This is east in this direction, and you can see we have a downhill slope. So the object now is to try to find the possibly older insects that have already left the body. We've already made the collections from the body. And these insects will migrate until they find fallen rocks and limbs, things that they can tunnel under. Trees are a good backstop for them. They'll crawl till they hit the trunk of the tree, then they may burrow down right in front of the tree. So they look for shelter. Thick clumps of grass may also be shelter because they can get in that root mat of the grass itself. So downhill slope, and what we thought was we could look in front of this tree, and this tree over here, and this whole area would be good. So you don't have to search in a 360-degree circle. You don't have to get out the forensic backhoe. You can simply look to where the maggots would probably seek shelter, how they disperse themselves out in the environment, and then search accordingly. So we're searching in a transect from the body out towards this tree, and this tree was about as far as we would go because we would assume that any that would hit the tree would pupate probably in front of the tree, between the tree and the body. This is just a photo that shows you how strongly attracted or repelled by light these larvae can be. They do not have eyes, but they can detect light through their skin. Prior to reaching that migrating phase, they are repelled by light. Light then means they're on the outside of the body, they're in danger of falling off the body, and they're exposing themselves to predators. So they seek darkness. And this is our test pig. This is a stake that holds up the screen covering of our test pig, and that's just a shadow of this stake. And you can see how the maggots that have ended up on the outside of the body are trying to stay out of the sunlight, and they've oriented themselves into that shadow. When they reach this dispersal phase, they become attracted to light, which is why they tend to orient themselves east and west. The rising sun in the morning tends to orient them in an easterly direction, and the setting sun in the afternoon tends to orient them west, as long as they have an open horizon and they can see the sun. So here's our tree for our point of reference. She has now moved from right over in this area. She's found a part of a fallen limb, so she's looking under that falling limb. You'd want to look in front of these clumps of grasses, and particularly in front of the tree. You want to move the leaf litter or any surface fall. They'll stay on top of the soil until they reach a spot where they feel sheltered and secluded, then they'll burrow straight down. So often if you simply remove the surface fall and expose the top layer of soil, you can find these migrating maggots. And again, the tree is back there, and that's where we're eventually going to want to search in front of, is that tree, but we're trying to find any that are still on their way out and maybe have not burrowed into the soil yet. Dig down just a couple inches is generally enough. You don't really need a shovel. You can use your hand. And in that area, just in front of the tree, we found these larvae. These were larvae that 24 hours prior to this picture were still feeding on the body. So in those 24 hours, they have reached that stage where they disperse from the body, they've crawled out towards that tree, they've crawled on that downhill slope, they've oriented themselves east, and they have burrowed into the soil. And here is where they will form that pupal stage, which is the cocoon stage between the larva and the adult. At this point in time, you still need to preserve some and keep some alive. The difference is when you have to keep these alive is they're post-feeding. So you do not need the aluminum foil and you do not need the beef liver. You can simply pick up these with some of their associated soil and put them into a container. So any evidence container with tight-fitting lid will work, and it should be properly sealed. Photography at this stage is very important. That shows us what stage they're actually in when you find them. If you were to have left these alone and come back 24 hours later, which we did just for the example in this photograph, you will find that those larvae have now turned into that pupal stage. Photography is very important here because you also notice there are different colors. This is still a maggot down here. Here we have a maggot. Now they become immobile, they start to darken up, and eventually they become very black. So these colors are of immense importance. It changes every couple hours. If you try to preserve them by placing them into that larval solution, KAA, they're going to die, of course, and it's going to cause a color change. If you try to keep them alive, their color is going to change quite rapidly because they're developing. So photography is really the best way to capture that color that's important to us. And if you have a photo scale, like a photo gray scale, lay that in the photograph so we can calibrate based on the photo gray. We can tell what color this actually is, and just based on the color, and if we know the species, we can get a relatively good time interval for you just based on a photograph. And you notice these are very dark. Right before the adult stage hatches out, that pupae turns quite dark. It's not red or brown anymore like you see in this picture. So they're very dark. See how much darker they are. It may take you a while to find where they went, particularly if you don't find maggots actively migrating, so it's somewhat like an Easter egg hunt. But when you find one, you generally find a large number of them because they tend to travel together and seek the same areas for shelter. At this stage, they're through feeding, so all you need to do is collect some and put them into a cup. You also want to preserve some, and you want to photograph. It's a good idea to use a hand sieve, just as we showed you in the other picture where she was sorting the soil underneath the body. That allows you to shake a lot of the sand or soil away from these pupae, and you don't want to pay to ship a bunch of heavy dirt to us. You want to pay to ship your evidence. So the more soil you can get away from them, the better off they'll be. And then you can place them on some very lightweight vermiculite instead of the heavy soil, and they will do fine in shipment, and we'll have very viable specimens when we get them to our laboratory. And again, you want to preserve some as well. Still, at this stage, you want to put a plain paper label inside of the cup, and you want to put an adhesive label on the outside of the cup. Everything should have two labels in pencil. So when you're done with that, you want to sit down and make sure that the rest of your entomology scene form is complete. You have a scene checklist that you need to go through. Make sure that you do all the steps in the scene checklist, and if you have completed your entomology data form and your scene checklist and not left anything out, you will do exactly like we would do if you called us to your crime scene. So there's really no need for us to be at your crime scene. You can do exactly what we do, and we can save our time for analysis in the lab to get you the information that you need. If anyone has any questions, there is a contact number for me as well as an email address. The website is there. The website contains kind of an outline form, most of the information that we will go over here in this course for discovery and recovery. The scene checklist are online in PDF format, as well as the death scene form, so you can go to the website at any time and download fresh copies of these forms that you need. It's always a good idea to keep some on hand, and make sure that you pre-configure your kits. You need the equipment that you'll be able to work with well before you're trying to respond to a scene and do it, particularly with the fly net and those featherweight forceps, which prevent you from doing too much damage to the larvae. Everything else you probably already have in stock on your crime scene. So ultimately you can put together your crime scene kit for less than 20 bucks. Fly net's 12 bucks, those forceps are about 3 bucks, and your kill jar is another 3 bucks. Everything else you should get locally and probably already have on your crime scene.